11.9 Volumes by Disk and Washer Methods 2. In our last lesson, we learned that if area R is bounded by fx and the x-axis, we can use the disk method, which is really just integrating a bunch of pi r squareds, where r is f of x. If an area is bounded by f of x and g of x, and say f of x is larger, then the volume would be the integral of a bunch of pi times fx squared minus gx squared, because we're doing the volume of the large minus the volume of the small, and that's called the washer method. But that's assuming that our area revolves around the x or the y axis. What if area R revolves around a different line, like y equals 1 or x equals 2? Well, here's an example. This is from Khan Academy. I have put the link in the notes. Sao Khan makes a nice video going through the calculations of this problem in detail. So you can always click the link and go here. I'm going to focus on the main points. In this example, area R is enclosed by f of x is equal to the square root of x, the x-axis, and x equals 4. We want to find the volume of the solid generated when R revolves around y equals 1. First of all, we need our endpoints. We know that we're going from x equals something to x equals 4. We're told about 4. The first endpoint, well, that's the intersection of y equals square root of x and y equals 1. That means that square root of x equals 1, which means x equals 1. And the other endpoint is x equals 4, as given in the problem. So we're integrating from 1 to 4. Well, you might think, okay, so first of all, we factor out the pi. We're integrating from 1 to 4. If this were revolving around the x-axis, then it would be pretty simple. It will be the integral of f of x squared dx. But here, and that would be true if we're integrating all the way down to the x-axis. But we're not. In this problem, we're only taking the area that goes down to y equals 1. It's shorter. It's shorter by how much? It's shorter by 1. So the integral is really the integral of f of x minus 1, and then the whole thing squared. I should mention that this is still a washer, not a washer. This is still a disk, a circle, not a washer. This is not like a donut with a hole in the middle. So that's why it's the whole thing of fx minus 1 squared, and not f of x squared minus 1 squared. Okay? So that's really going to equal to pi times the integral of 1 to 4 of square root of x minus 1 squared dx. In the Khan Academy video, they work out this integral in detail. We'll just use Wolfram Alpha to calculate the integral quickly, because our goal is to understand how we set up these integrals. So we're integrating square root of x minus 1, the whole thing squared, from 1 to 4. When we integrate this, we get 7 over 6. So the answer, the volume, has to be 7 pi over 6. Okay, that's it. Next, example 2. Let R be the region bounded by f of x is equal to x plus 4, g of x is equal to x squared plus 3, x equals 0, and x equals 1. So we have x equals 0, which is the y-axis, x equals 1. We have f of x is equal to x plus 4. That's f of x. We have g of x is equal to x squared plus 3. So we have this area R that we are revolving, not around the x-axis, but instead we're revolving around y equals 2. Okay. Well, first of all, endpoints. The endpoints is 0 and 1, x equals 0, and x equals 1. We were given those two endpoints. So our volume has to equal pi times, I'm going to write this all out, pi times our integral from 0 to 1. Okay. If we were integrating, if this solid is r revolving around the x-axis, then we would have a washer, and it would be f of x squared minus g of x squared, the whole thing dx. That's if we're revolving around the x-axis. We're not revolving around the x-axis. We're not doing the volume of this thing, f of x, minus the volume of this thing. We're not doing that. Instead, we're doing the volume of this thing, which is f of x minus 1, has length f of x 1, minus the volume generated by revolving this thing, which is g of x minus 1. So that's why instead of f of x squared, we should have let's use the right color. So that's why it should be f of x minus 1 squared. And it's still a washer, so we're minusing, but we're not subtracting g of x anymore. And instead of g of x squared, well, we're looking for this line segment, which is g of x minus, minus 2, not minus 1, because we're revolving around y equals 2. Sorry about that. So it should be f of x minus 2. And it should also be g of x minus 2, because that's the length of this segment. This is g of x minus 2, and that one is f of x minus 2. So we're integrating 0 to 1 of f of x minus 2 squared minus g of x minus 2 squared times pi. That's because it's a washer for this problem, not a disk. Let's simplify. So that means that this is equal to pi times the integral from 0 to 1 of x plus 4 minus 2 squared minus x squared plus 3 minus 2 squared, the whole thing dx. Okay, that's equal to pi times the integral from 0 to 1 of x plus 2, the whole thing squared, minus x squared plus 1, the whole thing squared, and this whole thing dx. Okay. We'll use Wolfram alpha to calculate our integral. So this time we're integrating x plus 2 squared minus x squared plus 1 squared from x equals 0 to x equals 1. Okay. And when we do that, we get 67 over 15. So this whole thing, the volume has to equal 67 over 15 pi. Okay. So that's the volume of this washer using the washer method. So I've also typed this out neatly in the notes. You can always refer to them. Example 3. This is from AP Test 2004, Form B, Question 1. Let R be the region enclosed by the graph of y equals square root of x minus 1, the vertical line x equals 10, and the x-axis. B. Find the volume of the solid generated when R is revolved about the horizontal line y equals 3. I have typed this out in Desmos. Here we have our f of x, which is square root of x minus 1. And it's bounded. We can see that the bounds are 1 and 10. So first of all, we know that our endpoints are x equals 1 and x equals 10. Why? Because x equals 10 is given to us. And we know that y equals 0 when x equals 1. So that's why the endpoints are x equals 1 and x equals 10. Okay. So we know our integral is going from 1 to 10. And it's going to be dx for part B. Going back to our graph, we know that this time we're not revolving around y equals 0. We're revolving around y equals 3, the purple line. In other words, what we have here is we have this thing, we have this area, R, and it is revolving around y equals 3. Okay? So we should notice then that this is a washer problem, not a disk problem, because when we revolve this, there's this solid region, and then there's this hole in between. Okay. Anytime we have a washer problem, we're subtracting a large volume from a small one. What is our large volume? Our large volume is going to go from 3 all the way to 0. Okay. So what is that? Well, that's going to be just 3. That's 3 minus 0. We're going to subtract that by the small volume. The small volume will go from here to here. How long is this line? Well, this line is going to be 3 minus our function x minus 1. Because we're going from x square root of x minus 1 to 3, but 3 is always larger. Okay. So, using the washer method, our integral, well, our volume is going to equal pi times our integral from 1 to 10. Our large volume, which is 3 squared, minus our small volume, which is 3 minus square root of x minus 1 squared, the whole thing dx. Okay. We can use a calculator to do the integration here. They expect you to do that on the AP test. So to integrate, 3 squared is just 9. 9 minus 3 minus the square root of x minus 1. That thing squared from 1 to 10. When we do this integral, we get 67.5. So 67.5 pi. 67.5 pi is about 212.058. So that's our volume for B. Okay. Next, part C. Find the volume of the solid generated when R is revolved about the vertical line x equals 10. We're revolving about x equals 10. So this time we have this region revolving about a vertical line, so we're going to use dy for this one. This time, notice that we have a disk, not a washer, because the whole thing, this thing, is going to be a circle. Okay? We're revolving a disk, not a washer. How long is this line? The line goes from 10 all the way down to our function. What is our function? Well, so for part C, we want our function in terms of y. Y equals the square root of x minus 1. That means that y squared equals x minus 1, which means that y squared plus 1 equals x. Therefore, our function is really f of y is equal to y squared plus 1. So our washer is going to have radius that goes from y squared plus 1. So this function is y squared plus 1 all the way to 10. So the length of the radius must be 10 minus y squared plus 1. This is a disk. We're using the disk method, not a washer. So the volume is going to be pi. Integrating. What are we integrating? We're not integrating from 1 to 10. We are integrating from 0 to 3 for the y. So we're integrating from 0 to 3 of 10 minus parentheses y squared plus 1, close parentheses, the whole thing squared dy. Okay. Again, we'll use Wolfram Alpha to just do this calculation. We're integrating 10 minus open parentheses y squared plus 1, close parentheses, the whole thing squared, from y equals 0 to y equals 3. Okay. We get 129.6. So this whole thing is equal to 129.6 pi. 129.6 times pi is about 407.150. So the volume is about 407.150. Again, I have typed up the notes more clearly for you here. You can always go back. So the biggest challenge really is we're going to be, if we're revolving around, say, y equals 1, then we'll be doing f of x minus 1 or 1 minus f of x, depending on which one is larger. We're still going to be either doing disk or washer. We have to be very careful about thinking about which one applies. It's just that if y is 1, then we do f of x minus 1 or 1 minus f of x. If x is 3, then we do g of y minus 3 or 3 minus g of y, and so forth. Okay, so that's it for this video.